Hello friends, in this video we will be discussing about a chemical phenomena that we are quite familiar with. Yes guys, as you can see I'm gonna talk about rusting. Now let's have a look at what is rusting. Rusting refers to the formation of rust, which is a hydrated form of iron 3 oxide on iron surfaces and structures. Rust is formed as a result of an electrochemical redox reaction between oxygen and iron in presence of water or moisture. As you can see in this figure as well as in previous figures that rust is physically a red flaky substance that easily crumbles into powder. Rusting is a serious issue faced by the iron industry worldwide. This is evident from the fact that almost 1 by 7th of all the iron production goes to replace the iron lost by rusting. Now let us have a look at what is happening chemically while rusting happens. Before that, we have to look at this electrochemical series. We can see that this oxygen and H plus are situated diagonally above this iron solid. So it is possible to build a galvanic cell involving this oxygen, water and iron so that a spontaneous redox reaction can occur. This is the schematic representation of an iron surface in contact with both atmospheric oxygen as well as water. Here you can see a cathodic area as well as an anodic area. The cathodic area is that portion of the iron surface which is in direct contact with both atmospheric oxygen as well as water. In anodic area, there will be no direct contact with the atmospheric oxygen, but there will be contact with the water. Now, let us have a look at what are the redox half reactions occurring at the cathode as well as anode. At cathode, we can see that this oxygen is getting reduced by 4 electrons to form water in presence of H+. On the other hand, at anode, Fe is being converted to Fe2+ by the release of electrons. So, if we add these two equations, that is cathodic and anodic equations, we will get the net reaction as 2Fe plus 4H plus O2 giving 2Fe2 plus 2H2O. Further, this Fe2 plus ion, that is ferrous ion, reacts with atmospheric oxygen as well as water to produce Fe2O3 dot XH2O, which is rust. We write H2O, that is, we write X as due to the fact that the amount of water in rust is variable. So the iron in this anodic area is getting converted to Fe2 plus and finally to rust and getting deposited in this area as rust. So the iron in this area is being consumed, and as a result of this a pit is developed here known as iron pit. Now let us have a look at what are the factors that enhance this process of rusting. The first factor is water. More water makes the process quicker. So in tropical regions where the humidity is higher, the rusting is faster. The second factor is the presence of impurities like salt in water. What you have to consider is that in this process, the electrons has to flow from the anodic region to the cathodic region through water. So, if salt is present in water, the speed is increased for this electron flow because salt water has more conductivity than pure water. So, rust is accelerated by the presence of impure water. For example, ships that sail into ocean have more risk of getting corroded than the boats that go through the lakes because ocean will have more dissolved salt in it than in lakes. Rust is also accelerated if the iron contains impurities such as more reactive metals. Example, the metal above it in electrochemical series like silver, lead, etc. Now, let us have a look at how we can prevent this process of rusting of iron. The first method is called barrier protection. In this method, a physical barrier is created between the iron surface and atmosphere. This is usually done by coating with paint, grease, etc. The second method is called sacrificial protection. In this method, the iron surface is coated with a more active metal like zinc, chromium, etc. so that electrons are lost from the coated metal rather than iron. Thus, iron will not go into the ionic state and won't be corroded. The metal coated is sacrificed instead of iron. That's why the method is called sacrificial protection. Zinc is the most common metal used for sacrificial protection. This sacrificial protection using zinc is commonly termed as galvanization. Another method is by application of anti-rust solution. In this method, a solution of alkaline phosphate or alkaline chromate is applied on iron surface, which forms an insoluble heat-resistant iron phosphate or iron chromate which prevents rusting. This is usually used in car radiators. That's all for today. If you want to see more videos like this, subscribe to our channel C for Carbon. Thank you.